The North Sea, a body of water known for its harsh weather and rich history, has long held secrets beneath its waves. Scientists, much like explorers of old, have always been charting these hidden depths, expecting to find a world that follows nature's simplest rules. They believed, as geology has taught us for centuries, that the layers of the Earth are stacked like pages in a book. The oldest, earliest pages are found deep at the bottom, while the newest, most recent ones lie neatly on top. It is a fundamental principle, one that has guided our understanding of the planet's long and dramatic story. But in a remarkable turn of events, a new discovery has shown us that sometimes, nature decides to rewrite its own rules in the most spectacular fashion imaginable. Deep below the seabed, where sunlight has not reached for millions of years, researchers have found something truly astonishing. It is a landscape that has been flipped completely on its head. Imagine making a layered cake, with a light, airy sponge at the bottom and a heavy, dense layer of fruit on top. Now imagine that dense fruit layer somehow sinking through the sponge, pushing the lighter cake upwards. This is precisely what scientists have uncovered. Huge sections of younger, heavier sand have mysteriously sunk downwards, pushing older, lighter material up and out of the way. This finding challenges everything we thought we knew about how the seafloor is formed and preserved over geological time. To describe this extraordinary phenomenon, scientists have come up with new, wonderfully simple names. The vast mounds of dense sand that have plunged downwards are now called sinkites. These are the heavy players in this geological drama, some of them stretching for several kilometers across the hidden landscape. The older, lighter material that was displaced and forced to float upwards has been named floatites. This material is made mostly of the microscopic fossilized remains of ancient marine creatures, creating a porous and lightweight layer. These floatites now sit above the very sand that was once deposited on top of them, creating an upside-down world buried deep beneath the sea. This process, where the natural order of rock layers is reversed, is known as stratigraphic inversion. While small examples of this have been seen before, never has it been observed on such a massive and breathtaking scale. It is as if a giant hand reached down into the Earth's crust and stirred it, leaving behind a puzzle for future generations to solve. This discovery opens a new chapter in geology, compelling us to look at the ground beneath our feet and our oceans with fresh eyes. It reminds us that our planet is a dynamic and ever-changing place, with powerful forces constantly at work, shaping and reshaping the world in ways we are only just beginning to comprehend. Uncovering this hidden inverted world was not a simple task. It required a special kind of vision, one that could peer through kilometers of water and dense sediment. Scientists achieved this remarkable feat using a technology called seismic imaging. This technique works much like a medical ultrasound, but on a vastly larger scale. A ship on the surface sends powerful waves of sound down towards the seafloor. These sound waves travel through the different layers of rock and sediment, bouncing back when they hit a boundary between different materials. It is a little like shouting in a large, empty hall and listening for the echo to return to you. The returning echoes are recorded by sensitive instruments, and each echo tells a story. Sound travels at different speeds through different types of rock. It moves faster through hard, dense material, and slower through softer, lighter material. By measuring the time it takes for these sound waves to travel down and back up, scientists can create a detailed map of the world below. They can see the shapes, sizes, and textures of layers that are buried far out of sight. This process allows them to build a three-dimensional picture, a virtual model of the Earth's crust, revealing geological structures with incredible clarity and precision. It is through this sonic artistry that the North Sea's secret was finally revealed. When the research team, led by Mads Hughes and Jan-Erik Rudjord, analyzed the seismic data from a specific area of the North Sea, they noticed something peculiar. The images showed strange, undulating patterns that did not fit with the expected flat, stacked layers. There were massive bowl-shaped structures, the sinkites, that had clearly punched down into the layers below. Above and around them were distorted dome-like shapes, the floatites, which had been squeezed upwards. It was a chaotic and jumbled picture, a clear sign that a dramatic geological event had taken place here long ago, disrupting the calm and orderly deposition of sediment over millions of years. The level of detail provided by modern seismic technology was crucial. It allowed the scientists not only to see these structures, but also to understand their composition. The data showed the distinct properties of the dense, heavy sand that formed the sinkites and the lightweight, porous, fossil-rich material that made up the floatites. Without this ability to see with sound, this incredible upside-down landscape would have remained a complete mystery, locked away beneath the seafloor. It is a testament to human ingenuity and our endless curiosity to explore and understand the hidden workings of our own planet, even in its deepest and darkest corners. So, when did this colossal seafloor flip actually happen? By studying the layers of rock above and below the inverted structures, geologists have been able to pinpoint the event in Earth's history. The evidence suggests that this great geological mix-up occurred around 5.3 million years ago. This was a time of significant global change, marking the boundary between two geological epochs, the Miocene and the Pliocene. The world was transitioning, climates were shifting, and the Earth itself was geologically very active. It was during this dynamic period that the conditions became perfect for this massive inversion to take place in the North Sea basin. But what could have possibly triggered such a dramatic event? The scientists propose a compelling theory. First, a thick and heavy layer of sand was deposited over a much lighter, more rigid layer made of ancient microscopic fossils. This created an unstable situation, like placing a heavy brick on top of a delicate sponge. The system was primed for collapse. The trigger, they believe, was likely one or more powerful earthquakes. The seismic shaking from these earthquakes would have fractured the upper sand layer, allowing the denser material to begin its slow but unstoppable descent into the lighter, porous layer below. As the heavy sand sank, it displaced the lighter, fossil-rich material, forcing it upwards through the cracks. This process would not have been instantaneous. It likely unfolded over a long period. But in geological terms, it was a sudden and violent reorganization of the seafloor. Over the subsequent millions of years, the ocean continued its patient work. New layers of sediment slowly rained down from the water above, burying the entire scene. This new blanket of sediment covered the sinkites and floatites, preserving them like a time capsule and creating the gently rolling seafloor that we see on maps today, hiding the dramatic story buried beneath. This explanation provides a fascinating glimpse into the powerful forces that shape our planet. It shows us that the Earth's crust is not a static, unchanging thing. It is a dynamic system where gravity, pressure, and tectonic forces are in a constant battle. The story of the sinkites and floatites is a dramatic example of what happens when that balance is suddenly and violently disturbed. It is a reminder that the history of our world is written in the rocks, and sometimes that history contains chapters that are more surprising and chaotic than we could ever have imagined. This discovery is far more than just a geological curiosity. It holds important lessons for our modern world. Understanding how these massive underground structures were formed has profound implications for a range of scientific and industrial activities. For geologists, it challenges them to rethink how they interpret subsurface data. The simple rule of older is deeper does not always apply, and this discovery proves that vast areas of the Earth's crust can be rearranged in ways previously thought impossible. It encourages a new level of caution and curiosity when exploring what lies beneath the surface, whether on land or at sea. One of the most critical applications of this new knowledge is in the field of carbon capture and storage, or CCS. CCS is a technology aimed at combating climate change by capturing carbon dioxide from industrial sources and storing it deep underground in geological formations. To do this safely, we need to be absolutely certain that the storage sites are stable and will not leak. The presence of unexpected structures like sinkites and floatites could dramatically change how fluids, like stored carbon dioxide, move and behave underground. Knowing that such inversions are possible will help scientists select safer and more reliable sites for long-term carbon storage. This research is also incredibly valuable for the energy industry. The North Sea has long been a major source of oil and gas, which are found in underground reservoirs. These reservoirs are often trapped by impermeable layers of rock known as seals. The discovery of sinkites and floatites introduces a new complexity to this picture. It could help explorers identify new, unconventional types of traps for hydrocarbons or, conversely, help them understand why some areas that looked promising turned out to be empty. It refines the geological maps used to search for resources, making exploration more efficient and successful. Finally, this monumental discovery leaves us with many new questions. How common is this phenomenon? Could similar inverted landscapes exist in other parts of the world, waiting to be found? The scientific community is buzzing with excitement and some healthy skepticism, and researchers are already working to find more evidence to support their model. The story of the North Sea's upside-down world is a powerful reminder that our planet is full of wonders. It shows that even in a place we thought we knew well, there are still profound secrets to uncover, driving us to keep exploring, to keep questioning, and to keep learning.